Hello everyone, and welcome to Group Adel's proposal for the Sky's the Limit student competition. For this project, we explored the impact of integrating natural daylighting strategies to the existing structure, the Clarendon Central Public School. To determine the best design integrations, various types of skylight and roof assemblies were compared regarding their thermal and physical properties, as well as the impact of the skylight's design on the school's daylighting. First, to review the scope of the project. The project will commence with protective measures to prevent damages to the components of the building, which will not be modified, such as the existing windows, which are to be protected with scratch-resistant plastic film, as well as the plywood on both interior and exterior sides of the envelope. The demolition phase of the project will begin with the removal and disposal of existing elements such as eavesdrops and downspouts. Existing heat trace and telecommunication cables will also be removed and preserved until reinstallation. The mansard roof assemblies on the east and west facades are to be removed as well, while the existing roof and parapet construction will be retained without their envelope components, such as insulation, plywood sheathing, etc. Existing skylights, exhaust vents, and gooseneck vents are to be carefully removed and disposed of. Finally, the existing roof assembly E1 will be removed, while the roof assembly E2 will remain in place. Any loose areas of the existing modified bitumen membrane on the roof assembly E2 are also to be removed. As part of the construction phase, the proposed roof assembly R1 will replace the previously removed E1 roof assembly. The existing roofing assembly E2 will be reinforced with a mechanically fastened overlay board and a 2-ply bitumen membrane. New skylights, exhaust vents, and gooseneck vents will be installed in the same locations that match their existing sizes. The parapet construction is to be extended vertically. Wood blocking is to be fastened to the existing parapet and extended parapet frame to be filled with semi-rigid insulation. The construction will be finished with all the typical envelope layers, while new eavesdrops and downspouts will be attached, and the existing heat trace cables and telecommunication cables will be reinstalled. Finally, existing interior finishes are to be repaired as needed. To choose our skylights, we looked into the artistic professional resources, according to the proposed roof assembly. Our team chose 2 different FF model series, which is one of the most versatile units among all the artistic products. Both products need to be customized to satisfy the 970 by 970 millimeter curb opening. The first product we chose is the PP Frost-Free Commercial Pyramid Curb Mount Skylight. This skylight is perfect for any flat or sloped roof application. Made entirely of high-quality materials, the skylight is designed and built to withstand harsh weather conditions. It consists of an all-aluminum curb frame that has been sealed with a PVC thermal break profile designed for mounting on 38mm curbs, which are dual-layer UV-stabilized acrylic-framed lenses, and a heavy-duty aluminum cap frame. This curb frame is constructed with rugged aluminum to withstand tough job site conditions. By using frost-free thermal technology, excessive condensation will be reduced and interior frosting will be avoided during winter months. The second model is the Frost-Free Commercial Pyramid Curb Mount Skylight with an aluminum curb. This carries over all the benefits in the other proposed model, but with an added benefit of a prefabricated all-aluminum curb. In order to install the curb, the Frost-Free Commercial Skylight is directly mounted to the roof deck of the building. The assembly is also resistant to harsh climates. Since it eliminates the need for an on-site construction of curb structures, this product is ideal for a fast-track skylight installation. Also contacted the artistic technical representative to gather more detailed information about the 2 proposed designs. The first model has a price of $1,288 per unit, and the second model has a price of $1,677 per unit. Both units have the same U value and solar heat gain. The PFF model has a low cost and it can be fastened to the site curb, but the premise is the roof curb structure needs to be installed during the roof renovation. Overall, we concluded that the second prefabricated skylight is better and is appropriate for the renovation. Although it comes with a slightly higher price, the model consists of extra insulation to provide better thermal performance. Next, we compared the existing versus the proposed roof assemblies to determine the best possible solutions. In terms of comparison, the existing E1 roof uses a 4-ply burr membrane with gravel, overall making a durable membrane with controlled drainage. The proposed R1 assembly has a roofing membrane with the use of PVC application. It does not provide ease for foot traffic with mechanical units due to the easy tearing in winter conditions and being a slippery surface when wet. The proposed R1 roof assembly has a greater thermal performance with the addition of an 88mm polysilo insulation, compared to the existing roof having only 100mm of insulation and in some spots dropping down to only 25mm due to the slope. The outcome of the insulation level is greater with the R1 assembly but fails to become effective after 15 degrees Celsius. Comparing the existing roof E1 and the proposed R1 roof assembly, each have their pros and cons regarding their material selection and application methods. Overall, the existing roof will only outperform the new proposed roof due to its reliability and multiple applications of materials. For example, a 2-ply air vapor barrier where joints can be overlapped as opposed to a single-ply vapor retarder where air leakage is possible in the R1 assembly. Regarding E2 and R2, the existing E2 roofs follows a similar assembly where the new modified bitumen membrane and rigid insulation that will remain. Whereas R2 is an additional application on top of where a 2-ply modified bitumen membrane and an overlay board for protection will be used. This follows a greater application in terms of sustainability, reuse of existing materials, and cost efficiency. Apart from that, the condition of the existing rigid insulation is also unknown unless inspected. This could be a determining factor of whether or not the thermal performance of the insulation will hold up to its rated R value. In conclusion, the proposed R2 roof assembly is the better option, mainly due to the insulation rating of the polysilo insulation. Using the existing E2 roof assembly reduces the cost and gives a greater cost efficiency, also containing a more trustworthy and durable products in its application. Next comes the comparison of the proposed versus existing wall types. It's important to know that the proposed wall type shows a little performance increase with the replacement of the semi-rigid insulation in place of the cellulose. Following are important details for the proposed design. The proposed roof assembly is shown first. One thing that needs to be considered is that the aluminum curb is to be extended to the deck sheathing layer to make sure that the thermal bridge area is well protected. For the roof drainage, we decided to use OMG's Sump Retro Drain. With this specific product, there is no need to fabricate a drain sump in the field, and there is no need to install or rework a drain. OMG's Retro Drain combines both drains and sumps into one easy-to-install product that maximizes the rooftop productivity and reduces flash leaks during installation. We also attached the following parapet detail to show its association with the new proposed roof. For both of the daylighting analyses we completed, we made the assumption that there was a sunny day with direct sunlight. Data was collected from the nearby YGK airport using historical data to complete the radiance light simulation. The existing windows and new skylight translucency was also assumed in this case. In analyzing the daylight received on the interior of the building through the skylights, as well as the existing windows in January, it's shown that even without interior walls, natural daylighting alone would not reach the center of the floor plate, meaning artificial light would be required to supplement the natural light to accommodate a classroom setting. The skylights seem to have little effect on daylighting within the space during the time tested compared to the same simulation without skylights. Comparing July to January, the skylights have a greater effect, drawing daylight deeper into the floor plate. Still, without interior walls, an artificial light source would be required to supplement this for a classroom setting. July sees more light entering from the east of the building, additionally being assisted by the skylights, which allows natural light to penetrate deeper into the building. To conclude, the skylights are not very effective in terms of daylighting, especially during the winter months. Additionally, considering the thermal resistance of the assembly. Compare this to the summer, they are much more effective at daylighting within the building. Suggestions that would better suit the program could be increased skylights sizes within key areas, more central to the building, therefore having a greater impact on the amount of light drawn into the center of the floor plate.